right.
Is your mic working today?
I am double checking. It is recording from the mic. The mic is active, and the recorder is going. Okay, so everything is good so far. All right. So let's go ahead and get started. What I'll do is I'm going to talk about the homework assignment because it's past due at this point. How long did it take you guys to do the homework?
2 seconds or 20 minutes.
20 minutes? Okay, well, that's about, okay. Depending on how long it takes to download and install it. Now, someone told me that going to one of the links, cost the security software to report it's a scamming or spamming website. Somebody told me that. Do you guys have that experience?
No.
Yeah, I did, but I continued anyway.
Okay. Now, which security software were you using?
Yeah.
Okay. Does it report a lot of false alarms or not really?
It has. It depends on websites. Usually, if it's like a website that maybe has some sort of tracking or something.
Okay.
Yes. Usually anything that has some form of tracking, so it'll just pop up as like, well, you should go to there and say.
I see. Now, did you go to LibreOffice or did you go to Portable Apps?
I went to Portable Apps.
Okay, Portable Apps may have more tracking going on, but if you go to LibreOffice to get the actual installed version, I think that would be that should be safe.
Yep. When I was getting towards the link for downloading, it just asked me about some username and passwords. I had no idea of. So because of that, I had to go to the Portable Apps and download there. And so I never got to the questions. People were saying that you have to answer some questions, so I just downloaded the file, made a new one, renamed the program for my own self, like my name and last name, get through the tools, save the file and upload it to you.
Okay.
Is that fine?
All right. Well, I'll take a look at how people, what kind of file people turn in, and then I'll give you guys feedback. Okay. I'll give you guys feedback. All right. So, are there any questions from last time? I think last time go ahead.
I have something about homework assignment. When I try to write the answers onto the document, it said it was read only. So I copied and pasted to a new.
Okay, I'm going to reopen it so that you guys can do it again. But this time I will show you guys exactly how to do it. And it's being recorded, so that's all good. Okay, so let me first, change that due date first. This homework assignment, the only intention of this homework assignment is to make sure that people have the right software installed and also have the right configuration of the software so that for all the future homework assignments we'll be good to go. What was I about to do? Change the homework assignment. Okay, so I'm going to change the homework assignment and change the due date to Thursday. Are there any complaints about changing the due date to Thursday? All right, so this is now due on Thursday at 10:30. All right, so I'm going to do the homework myself first, to show you exactly what you need to do. Okay. And for the purpose of this, I'm also going to switch my role to student first, so this will show exactly what you should be seeing when you do the homework assignment. And also for this purpose, I'm going to change my name to Riley. Okay, just so that you can see how you can change OpenOffice, so that it can remember your name instead of whatever name comes with the installation. I don't think it comes with any name in the original installation. All right. So the first thing I want to do is to make sure that I have LibreOffice installed. And you go to LibreOffice using a different way because you're using Windows for the most part, and I'm not using Windows. But it doesn't matter. You go to OpenOffice. Any application is fine. You can use Calc. You can use Writer. It doesn't matter because it goes through the same process. And once you're in LibreOffice, you go to Tools. You go to Options, and the first thing that pops up is already there. So I'm going to change my name to Riley. R-E-I-L. Is it just L-Y or L-L-Y?
What's your name? It's just
L-L-Y.
L-L-Y? It's actually my cat's name.
How would we know your kid's name?
Yeah, one is Red and one is Riley. All right, so now that I have changed my name, I'll go ahead and test and make sure that it will save it with my name. So with this empty document, I'm going to make it save. So I make it save as, and then go to my root folder, and I'll just give it a name. Just call it test. Save. And then I can go to File, Properties, and make sure that, oh, it did not save under my new name. All right, let's close it and open again. Sorry? Okay, I'm going to close the application itself, reopen it. Oh, wrong one. Go away. Okay, go back to the document, file, properties. It's still using my name. I guess I didn't make any changes. All right, save it again. File, properties. And this time it saved my new name as Riley. Let me close the door. Really loud. Thank you. Okay, so I want to make sure that the software now remembers my new name before I do my homework. All right. So when you do your homework, you have to be kind of follow the instruction a little bit, because otherwise it will be read-only. In other words, if I click this link by itself and open Office this way, well, it actually saves in this case. But in certain browsers, in certain operating systems, when you click the link, it will open up LibreOffice automatically. And when you do it that way, it will be read-only. The document will be read-only. So the one way to avoid that problem is to right-click and then use Save Link As. When you do it this way, you save it to a particular folder. Make sure you remember where you save it to. Okay, so I'll save it to my root folder, get calc, and then I can go back to my spreadsheet program and reopen the file from here. And then I can state the answers. Did you install OpenOffice? Yes. Did you download this file from the assignment link? Instead of clicking the link, you have to right-click and download. And the answer is yes. Did you open this document using calc? Yes. Did you customize LibreOffice with your own name? Yes. So when I'm all done, I click Save. And the best thing you can do is to close it first. Okay? If you have the document still open, and then you turn in your homework assignment, it is possible that you might have forgotten to save the document first before you re-upload the file. So the safest way to do it is to close the document first, then you know for sure that you have saved the document before you upload it. So at this point, I can switch back to my browser, scroll all the way to the bottom. I have uploaded something already, but I can always upload again before the due date. And I'll go ahead and choose that file. I think this part never worked well.
Wait.
I don't.
Yeah. You zoom out.
Zoom out.
There you go. Just look on the left-hand side there, in that window. There you go. And
Upload a file. There we go. Go back to Documents. Get calc. Open. Upload. Save changes. File uploaded successfully. And now we have the file uploaded. So that's how you turn in your homework assignment. And it's going to be the same process for all your future homework assignments too. So, and you can, if you turn in something that is not entirely correct, like you copied and paste or you open it using Microsoft Office, just do it again and turn it in again. As long as it's before the due date on Thursday, it will still be counted. Yep.
Will you give us feedback on what if we've already done that? just to make sure that.
If you have done it already, I would usually wait until the due date is over, then I would grade it. But if you want me to just specifically look into one, I can do it. It's I just don't want to have to look at all 50 at the scale is now different. Talking about class size, we used to have a problem that is in the opposite direction. If you remember a few years ago, 2 or 3 years after the dot bust, like the Silicon Valley collapse, the biggest problem we had at that time was not enough students. Enrollment was so low that sometimes we have to cancel classes because of not having enough students. Every class needs to have at least 22 students in order for the class not to be canceled. This class right now, in this room, we have probably over 50 students. So things that I could do back then, like I can check your homework before I actually graded. It's sometimes not feasible anymore when I have 50 students instead of 22, and I get paid the same. And they complain that there's no pay cut in the Los Rios district. Sacramento Bee ran an article, I think about 1 or 2 years ago, and they said, well, all the government agencies and private sector, got pay cuts and whatnot. How come employees at the Los Rios district did not get any impact? Well, it's just in a slightly different way, but it's still impacted. All right. Are there any questions about the homework assignment? This particular homework assignment? No questions. All right, if there are no questions, we'll go back and we'll start to talk about actual kind of real topics, technical topics today. This link is only for your information. Last time I forgot to mention one thing because I was assuming everyone in this class is going to be a computer science major, but I now remember that some of you are engineering major and math majors. If you're a math major, you can consider taking computer science as a minor. If your 4-year university has a minor program in computer science, consider that. I mean, because math and computer science are very related. It'll be helpful. Okay, so now we're going to move on, and we'll talk about topic 2. We're moving on to topic 2. This one here explains the role of algorithms in computer science and programming. An algorithm is a method. It's a formal method to do something. In other words, when you use the word algorithm, you can expect whoever is reading the algorithm to understand it exactly the way you meant. Okay. I don't know. I'm not sure whether I can just skip this topic or not, because I would never ask any questions about developers and algorithms in the test, so do you guys still want to go through that or not? No. I'll leave it up to Steve Ballmer to emphasize the importance of developers. Do you guys know what I'm talking about? Some of you do, some of you don't. Well, we can always look it up. That always wakes up people. Okay, Steve Ballmer. He has a lot of entries. I think it's only one L. It's kind of slow. And I don't know which one is the original one because I don't want the remix one. The remix one is a little bit over the board. We'll try this one. This is
Ladies and gentlemen, Steve Ballmer!
That's not the developer one. That's also an interesting one, but it's not a developer.
Sorry.
too.
The audio surf one would have it, as
Which
long
one?
as they disable the effects. The audio surf one.
Sorry?
Audio surf. The
Audio.
yeah. As long as they disable the effects. This other.
No, but this is not the right one. The music is actually the actual music in this one. But this one is not the developer one. This one is just him going kind of boinky. But he repeated, developers like 20 times of the best of Steve Ballmer. I think it might be this one. We'll give it a try. No, it's not.
It's a one.
No, it's the wrong one.
And in the day and age of the
Yeah, he
Windows
was like
developer,
sweating.
Hmm?
Really, he was sweating profuse. Like you could
Yeah.
see his shit.
Yeah, yeah.
So it's that one where he's the blue one.
Yeah, well, you guys can look it up later. Okay, you guys can watch it on your phone. Just remember to turn down the volume a little bit. Yeah, he came out of stage and then he was, chanting, developer at least 20 or 30 times until he was panting. And then the last few words in the video, I think it was, I love this company, and that was the end of the video clip. Anyway, what do you think Microsoft would do without developers? What is a developer, by the way?
Software engineer.
They're not exactly the same thing. I'm not sure whether we talked about that, the differences between those two terms. A developer is also called a programmer or a coder, which is basically at the bottom of the totem pole in terms of software development. A software engineer would do some of that work, but also do the architect of the software, to do the design. In other words, when you guys want to find a job, after college, you want to shoot for a software engineer's job and not a developer's job, because a software engineer gets better pay and also get to design the architecture of the software. A developer, on the other hand, will look at the architecture designed by somebody else and implement exactly just that. Yep.
Well, Microsoft, I don't know if you've ever been to like Glassdoor.com, but they tell like all the salary reports of the positions at certain companies.
Mm-hmm.
And Microsoft actually has software development engineers.
Okay.
So what's the difference between software engineer, software developer, software development engineer?
Okay,
What's
it depends on the company. You have to look at the job description in that case, because the terms are different. Most companies, when they use the term developer, it is actually the same as a programmer or a coder, and that's usually a lower level job where people tell you exactly what the software should be, how it should be implemented. You're just handling the details. In other words, you're kind of more like a contractor, where the design of the bathroom or the kitchen is already done, and what you're doing is just lay down the tiles, the grouts, put in the sink, oh, okay, you're supposed to drill a hole here on the countertop, and you have to drill exactly at that location. On the other hand, a software engineer is more like a mix of a contractor, but also an interior designer, where you can actually talk, you have some input into the design itself. Like, I don't think this is a good place to put a faucet, maybe over here, or we can change the sink from here to here, and so on and so forth. So you want, at any rate, you want a title that has an engineer in it, or scientist, computer scientist. And because computer science has the word science in it, it is not an actual science. You guys know that, right? Any subject that has a science in it is not an actual science. Actual sciences do not have science in the name. Like physics. No one says it's physics science or physical science, it's just physics. Chemistry, it's just chemistry, not chemistry science or chemical science. So computer science, the name kind of gives it away. Later on, we'll talk about whether computer science is actually a science and what do you actually need in order to succeed in a computer science program. We'll talk about that in topic 4. All right. So now we're going to get started with topic 2. Topic 2 talks about all the really, really basic stuff of programming. involving variables, assignments, expressions, and sequences. In other words, how to do things step by step. Okay. Many of these terms or many of these symbols may look familiar if you have taken a few math classes. Yes?
You were going to tell us what the new homework was, but then you got sidetracked with LibreOffice. The homework that was going to be assigned today,
Yeah?
you never actually told us what it was.
There's no new homework today.
Oh, there's no new homework?
There's no new homework today. It's just an extension of the homework that was due today.
Okay.
Yep. So there's no new homework assignment. It's just downloading a spreadsheet, put in a few pieces of information,
Okay.
save, upload, and that's it.
All right.
Yep. All right. So let's go ahead and take a look at some examples. But instead of looking at this example, let me just switch gear. It's all in here. I don't really like to read my own notes. But let me just go ahead and show you something, and you can tell me what it means. All right. Okay, what does that mean? Well, yeah, I can hear different opinions, okay? Because it is ambiguous. It's very ambiguous. If you encounter this in a math class, what does it mean?
X equals 6.
It's a statement that that states x does equal to 6. It has the same value of 6. Other times, you look at this, it can be a question, right? Does x equal to 6? It can be a question, it can be a statement. But in mathematics, we don't ever look at this and say, well, x may be something else, but from this point on, it is 6. But that's the meaning in computer science. Okay? And that's why in this class, we never use the equal symbol this way. If I want to make 6 equal to 6, I use the left arrow symbol. I cannot use a left arrow using a plain text editor, but this is the symbol that I use for changing the value of x to 6. Okay. We'll get to this part later, but I just want to point out a lot of things where someone who has a lot of background in mathematics, they look at the notation in programming, it can be confusing because the same symbol means something that is completely different. So we'll go ahead and start with this example now that I have explained that part. So we'll start with an example of some mundane task that nobody would do anymore these days. In the good old days, you receive your credit card bill through the mail, not from your email. You don't go online to check your credit card bill. You actually get it in the mail. Now, if you ask me, the security of that is actually lower because the postman can easily put it into somebody else's mailbox. And that's why in your credit card bill, they don't show the entire number anymore. They only show the last 4 or 5 digits of your credit card. So that even if the statement is sent to somebody else, they don't have the actual information necessary to start to use your credit card. But anyway, we're just assuming that you get your credit card through the mail, and you want to pay your credit card bill using a check that you're sending back to the credit card company. Who does that anymore these days? Nobody. We all pay our bills online. But let's just say that this is the the way we do things. Now, because this is back before the internet days, if you want to keep track of how much money you have in your checking and your saving account, what do? Sorry? Yep, you have to keep track of your balance. Okay, whether you call it a ledger or just a expense tracking book or whatnot, it doesn't matter. But you have to do it by hand. So every time you pay some bill, writing a check out, you have to remember to put that entry into the book and say, okay, I don't have that much money in the bank anymore. It is decreased by this amount. Now, on top of this, let's just say that you also want to keep track of how much money you have spent through a particular credit card. Maybe you have a gas card, for a Shell card or a Chevron card just for gas. So you might want to keep track of how much money you spend on fuel every year. So it can make sense to keep track of your annual total expense for a particular credit card. Are there any questions about the 4 things that I want to do? Okay, well that's good because I know most of you already do everything online. I think at some point I have to change my notes. Because this will become more and more removed from how people actually do things. The next slide talks about what a variable is. A variable is an object that can hold a particular value, and the value can change over time. Okay? You can call it an object, you can call it, an item, but it's just something inside a computer that can store a particular value. But that value can change over time. So one moment it has a value of 3, the next moment it can have a different value, 6, 10, it doesn't matter, but it can change. A variable has to have the following things, certain attributes. First of all, it needs a name. Because without a name, it would be pretty hard to say, oh, I want to refer to that variable, or that variable, or that variable. Okay, which one are we talking about? So a unique name is really helpful, because now we can just say, I'm referring to variable X, I'm referring to variable Y, I'm referring to variable Z. As long as those names are unique, which means there are no duplicates in the program, every time I mention the name, I'm only referring to a specific variable. The type of a variable is important, especially for those of you who are going to move on to cisp300, because C, as a programming language, is a strongly typed language. But in this class, at least for now, I'm not going to talk about the type of a variable just yet. Okay, so for the time being, all variables that we deal with, they're only used to store numbers, particularly integers. Okay, so the type is not important at this point. The state or the value of a variable is important, because at any particular time, a variable has to have a value. Are there any questions about these 3 attributes of a variable? You can just ignore type for the time being. So there are only 2 attributes that are important to us at this point. Yep, go ahead.
So the value means like how important it is?
No, how much, what is the value stored in the value,
Okay.
in the variable. Okay, I can give you a few examples. So if I want to use, a little post-it as a particular variable, I will need 2 things. First of all, I need a name. Okay, so let's just say that this is variable X. Well, I need a name because when I execute a program, I might need a few variables. So the next variable, I need it to have a different name. In this case, it is Y. And yet, I can have another variable that has a different name. Let's call this W. Now, with the name W, X, Y, and Z, and A, B, C, I, J, K, and so on, I can now easily refer to a particular variable without any confusion. Is that okay so far?
Yeah.
But on the other hand, I also have a value associated with a particular variable. In this case, each post-it represents a variable, so it can also store a value. So maybe this variable currently has a value of 5, this one has a value of 16, and this one has a value of, say, 3. Is that okay? So it has a name, it also has a value. But the value can change over time. In other words, later on, as I run the program, I can decide that, oh, W should not store this value of 5 anymore. I want to update its value to 23. In other words, I can change the value of a particular post-it. But at any particular time, it has only one particular value. Once I change the value from 5 to 23, it would have forgotten the old value. So this is not a very good analogy, because you can see that I crossed out a 5, but an actual variable would not remember its value prior to the change. Is that okay? Right? So in the example that we have talked about, how many variables do we have? The first one is X. Now if you go back to the previous slide, X is the amount of, is the actual credit card balance of a particular month. Now that does change over time, because from month to month I may not have the same balance. So X does change over time. There are at least two other variables. One is available funds, which is how much money is in my saving account or checking account. And then the other one is the total expense of a particular credit card. Because every month as I pay or as I get my paycheck, the available funds variable will change. Every time I pay a bill by check or something else, I will have to decrease the amount of that particular variable. Are we doing okay so far with identifying the variables in this particular example?
So there's 3 variables.
There are 3 variables. One is X. The next one is available funds, which is how much money do I have in the bank, and the last one is the total expense of a particular credit card, because I want to add up all the expenses for that year. Any questions at this point about the 3 variables? Questions? All right. The next slide talks about expressions and assignments. So we'll go ahead and start with assignment first. An assignment statement is the most basic step that a particular program can perform. There are everything else are built on top of assignment statements. An assignment statement has a form like this in this class. LHS stands for left-hand side, RHS stands for right-hand side. Now these terms, LHS and RHS, right-hand side and left-hand side, seems somewhat arbitrary, but they are actually not arbitrary. Okay, when you move on to a 4-year university, some of you may take a class in compiler designs or formal programming languages. In those cases, the term left-hand side or L value for left value is actually a formal term. Okay, but when you look at a statement like this, what does it mean? What is it actually doing? The left-hand side or LHS specifies which variable we are going to update. In other words, it has to mention the name of a single variable that we are going to change. The right-hand side RHS specifies the new value, the value that we want to change to. Are there any questions about the roles of the left-hand side and the right-hand side? Yes?
Do you read it and then to the left, or do you read to the right first?
That's a very good question, because it seems a little bit backward. And that's why I use a left arrow to indicate the flow of information. Okay, so when you read the rest of the notes here, in an assignment statement, the right-hand side is always evaluated first. In other words, you just ignore the left-hand side, you evaluate the right-hand side first. The right-hand side will always evaluate to a particular value. That value, in return, will be used to update the variable specified on the left-hand side. Does that answer your question?
Yes.
Okay, excellent. All right. So just remember, when you read an assignment statement, it is backwards. It is backwards because you have to evaluate the right-hand side, then you move on and change the left-hand side to that value. Why it is backwards, I do not know. I think it has to do with how we specify in mathematics. We always start with a variable and it equals to something else. So it might have started out that way, but now all programming languages use this rule. Okay. The next slide talks about something that is really easy to understand. So in this case, we have a variable called AE total expense, American Express total expense, and that's on the left-hand side. The right-hand side is a 0. What do you think is the effect of this particular statement? Does anyone want to give it a try?
Total expense is set to 0.
It's reset to 0. It's cleared. Okay. You can there are many names to refer to the action, but in the end, what happens is we are forgetting.
Beginning.
Sorry.
Like it's the beginning, starting.
At the beginning of a year, this is what I want to do because I want to reset the total expense of that particular credit card. Okay, so once again, we evaluate the right-hand side, but this time the right-hand side is very simple. It's a constant, just a 0. And then we use the right-hand side value, which is 0 in this case, to update the left-hand side. So AE total expense as a variable would now become 0. Will I be able to tell what it was before this statement? No, because variables can only store one single value at any particular time. So after you change it with an assignment statement like this, you cannot go back and say, oh, before this statement it was so whatever amount. Not with this kind of assignment statement. The next slide talks about, it looks really confusing because now I want to say AE total expense is getting a new value, but the new value is AE total expense plus X. Now that looks really confusing if I don't use the left arrow symbol. If I do not use the left arrow symbol, which is how most programming languages do it, what is X gets X plus 1? What does that mean? It depends on the class, obviously. If you give your math professor a question like this and ask your math professor and say, what is X equals X plus 1? What do you think would be the answer? If you have a kind, professor, probably a chuckle. If you have a mean math professor, you might get some. Your math professor may be disappointed that you asked that question. If your math professor just wants to give you a plain answer and not really get too much into saying something other than just the answer is false, not true. Why?
0 can equal 1.
Exactly.
Because no matter what X has as a value, it can never equal to that value plus 1. Because in math, X equals X plus 1 is asking, does X equal to X plus 1? That's what this particular statement means in mathematics. What about in computer science, in the context that we are talking about here? We are actually talking about an assignment statement, not a check whether they are the same or not. Now that really changes everything, because when you look at this as an assignment statement, what do you do with an assignment statement? What do you do first? You evaluate the right-hand side. Well, X has a value at all times. So when you evaluate the right-hand side, which is really just this part here, you take the value that X currently has and say, okay, we'll just add 1 to that value. That becomes a new value, right?
Right.
Well, what do you do with that new value? You just have to, as a second step of an assignment statement, you store that new value into X. In other words, if X had a value of 5, it becomes 6. If X had a value of 20, it becomes 21. Are we doing okay so far with that concept? Because this can be confusing, because how can we change something when it is used to specify the value that it will be changed into? It's not a problem, because we always evaluate the right-hand side first, and then we store the value, and we are done. We never go back and say, oh, but the value just changed, let me reevaluate the right-hand side. No, we do not reevaluate the right-hand side. Yep.
So the right-hand side is a tool to update the left-hand side, right?
The right-hand side specifies the new value of the left-hand side.
Okay. So it's like a sort of function for the left-hand side.
Well, the
But
word
as you
function
said
has a very
before-
specific meaning, so I'm not going to use that word. It really just specifies a value to update the left-hand side with.
Okay. Because this example with the numbers is really comprehensive. So I'm trying to say, can you use the same rules to the different methods, different problems when having this kind of examples where I don't know how to say it correctly, as a total expense, for example.
Well, with a total expense, we actually have an example here, and I hope I have fixed the values. Okay, so let's go back to our example here. So we'll say that before this operation, my current AE total expense is $263, and the balance this month is $71. So the question is, after I process the bill for this month, what will be my total expense on that particular credit card. Well, the expression is this one here. This is the assignment statement. So the assignment statement, and whenever we have an assignment statement, we evaluate the right-hand side first. The right-hand side specifies just, an addition, the sum of AE total expense, which is 263, and X, which is 71. The sum of that is 334. Is that okay?
Mm-hmm.
What are we going to do with 334? Well, the assignment statement says that we have to update the left-hand side. The left-hand side is AE total expense, so that means AE total expense will now be updated to a new value of 334.
So it changed from 263 to 334.
Yes.
The left hand side.
That will be the effect of this statement.
Okay.
Assuming AE total expense starts with a value of 263 and X is 71.
Thank you.
Mm-hmm. Sure.
So,
Yep.
question. On paper, how to write the expression?
How do you write the expression?
Yes. For the
Yes.
left hand side.
For the left-hand side?
Yes. You use the new number or the old one? 263. Which one you are going to write now?
Oh, you're talking about how do we represent the value? How do we keep track of the value of a variable? We'll talk about that.
Oh, okay.
Yep, that's a good question.
Same question.
Okay. All right. So let me just kind of repeat the question that you had. The question is, how do we keep track of the value of a variable as we go through these statements? That's a very good question because this is the only class where I require you to keep track of the value of every variable in a program. In your next class, the C compiler or the debugger does not give you any ability to keep track of the value, which is a good thing because you don't have to do everything that's tedious like we have to do in this class. But it's also kind of a bad thing because you cannot really debug a program easily without knowing how a variable changes its value over time. So the next slide answers your question because it is about how do we visualize the variables and the changes of the variables. So to do this part, let me use a different example, and I'm going to give you an example that is related to what we do, and I always use a spreadsheet to handle examples. So what we'll do is we'll have a particular variable x. We'll give it a value of 5 to begin with. We'll give y a particular value. We'll give it 3. Doesn't really matter. And then I'll just say that x gets x plus y. Okay, those are the only 3 statements that I want to execute. And these are the line numbers. I know the row number is exactly the same as the line number, but when you print it out, unless you know how to print the row number doesn't show up on the printout, and that's why I repeat this here. And this is also something that you will have to do eventually, is how to open up 2 windows on the same document. So this is a spreadsheet, it is a single document, but I can open up a different window by going to the window menu and then select new window. So what it does is it opens up a new window, but it's actually on the same document. In other words, if I resize and put these side by side, you can see that they're both referring to the same document. If I make any changes here, okay, it also updates the other side because they are really the same document. Are we doing okay so far with this part of using LibreOffice? It's okay? All right. So the trick is go to the window menu and then specify new window. It will open up a new window on the same document. The reason why I do this is in this class, I always use one sheet to represent the program that I'm keeping track of. But I will also keep track of another sheet so that I can see what is happening to the variables. Okay? Now, when we keep track of what is happening to the variable, we have a few things to keep track of in this case. Line number is always a column that you have to have. In other words, not only am I keeping track of, oh, the current value of this variable is something, I want to keep track of everything. In other words, I want to remember right after line 1, this is the value of this variable. Right after line 2, these variables have these values. Right after line 3, that's, these are the values of the variables. In other words, if you look at a spreadsheet horizontally, if you take a slice like this, every slice is a complete description of all the variables at a particular time. When you look at it this way, then each column represents, a particular variable. In this case, how many variables do we have? We have 2 variables. We have x and then we have y, even though one of them only got changed once and not twice. So when you look at the spreadsheet using columns, each column represents a trace of how the value of that variable changes over time. Is that doing okay so far? If you want to look at this as a movie, okay, a column is the script of a particular character. When you look at it horizontally, this is a particular frame in a movie. Is that a good analogy, or does it make it worse? Sometimes I pick analogies that are like not really good. It makes things worse. This one is okay? All right. X is an actor. This is the script of X. Y is an actor. This is the script of Y. Not so much the script, but what the character does in a movie. This is a frame. This is a frame. This is a frame in a movie. Is that okay? Yep. All right. So you might think that we will start with line 1, but that's not true, because there is something before line 1 that we have to document. It is called a precondition. In other words, before we start to run this program, what do we know about the variables, in this case just x and y? Now that is important, because sometimes you may not be given anything. We don't know anything about x, we don't know anything about y. Like in this case, I can just say I don't know anything about x or y. But other times, your program may start with certain values in the variables already as the input of the program. So it is important to remember to state a precondition. Well, since in this case it doesn't really matter one way or another, I'll just say that I don't know anything about x nor y before the program starts to execute. I just use a question mark to represent unknown. Now you cannot leave it blank, because if you leave it blank, that means you're not stating anything. When you put down a question mark for pre, you're stating something, you're saying something. You're saying that I do not know what the value is. Not that I forgot to specify that I do not know the value of x. Are there any questions at this point about the line called pre? It's the precondition. Now, when we move on to line 1, we are stating what is the value of x after that line executes. Not before, but after. What do you think is the value of x after line 1 executes?
8.
Line 1. Line 1, I'm just focusing on line 1. 5. That's right, because it's an assignment statement. We evaluate the right-hand side, which will give us a value of 5, and then we use it to update x, because it's the left-hand side. As a result, x is now updated from some value that we don't know to a value that we do know. It is 5. What about y? Did we do anything to y? Not yet, so it will still be unknown. Let's move on to line 2. After line 2 executes, what do we know about x?
5.
It's still 5 because we didn't do anything to x on line 2. What do we know about y after line 2?
3.
It has a value of 3 because it does update y to a value of 3. And then we are now asking after line 3, what do we know about x?
5. 8.
It's 8 because remember we evaluate the right-hand side first. The right-hand side is x plus y. X before line 3 has a value of 5. Y before line 3 has a value of 3. 5 plus 3 is 8. On line 3, we use 8 to update x itself, and therefore x after line 3, x has a value of 8. But y will still have a value of 3 because we didn't do anything to y on line 3. Are there any questions about why this is 8? Because that's really the most important part of this trace. Yep.
It's not. Why are you using 2 sheets?
I'm using 2 sheets because later on, we'll have loops and other things. So one sheet may only be like this long. The other one will be a lot longer. So this makes it easier to keep track of the program and the trace at the same time. I understand that with simple programs, you really don't have to do it that way, but later on we'll have more complex algorithms. So might as well just start using this technique from day one. Yep.
So you just press a new window and then you have another one that you put.
Correct. Well, there are 2 things. There are 2 things happening here. One is that I have 2 windows on the same document. So I have one window here and I have another window here. Each window is basically a portal into the same document. But they are also on different sheets inside the document. This one is on sheet 1 and this one is on sheet number 2. So they're actually looking at different parts but of the same document. Yep.
Is there a way to make it so that when you update like sheet 1, the value for X, it would update the page in sheet 2 for the column of X?
Yes, but it's relatively complex. So I don't want to talk about that in this class. But it's a spreadsheet kind of thing that you can do.
Can we write the same algorithm for y, replacing the x? Like y arrow x plus y.
You could do, well, I can add a line for to change y too. I mean, I can
For
basically.
the 4th line, because.
Well, let's go ahead and do a 4th line here. Okay, so we are going to change the program to have a 4th line. I can also upload this document, so you guys don't have to spend too much time just copying it. Okay, but somebody has to remember to save and upload it later on. Okay, so let's say line 4 is doing something to y, and I can just say y gets y plus 2. Okay, it doesn't really matter what it is. Okay, now we have to track that line 2. After line 4, what is the value of x? Does it change x?
No.
No, so x would still have a value of 8. But what about the value of y? Remember, it's an assignment statement. We evaluate the right-hand side first. When we evaluate the right-hand side, y plus 2, before line 4, y still had a value of 3. 3 plus 2 is 5, so y will now be updated to a value of 5. Are we doing okay so far with this example? Okay. Now, let's just say that this is the end of the program. If this is the end of the program, in the trace, I would also use a word called post to say that we're done. Okay? In mathematics, it's the same as a QED. It's just a marker to say that we are done tracing this program at this point. Are there any questions about the visualization of this particular algorithm? No questions? All right, very good. Well, we have just talked about the several things that I mentioned that I will talk about. One would be the concept of a variable. X is a variable, y is a variable. When you look at this way, when you look at x and y this way, you can quite visibly see that they are changing. The value of the variable is changing over time, and therefore the name variable. We talked about expressions. An expression is nothing more than expressions that you already know. X plus y is an expression. Y plus 2 is an expression. 5 is an expression. 3 is an expression. We talked about assignment statements where we evaluate the right-hand side first, and then we use the value of the right-hand side to update the value of the left-hand side, or update the variable specified by the left-hand side. And what about the concept of a sequence? What is a sequence? Well, in this program, it is a sequence because I can only start with line 1. After line 1, I can only execute line 2. After line 2, I can only execute line 3. In other words, the order of these statements is important. If I change the order of these things, the result will be different. Is that making any sense? And that's why it is called a sequence, because I have to perform these particular statements in the order specified. I cannot randomly change the order and say, oh, we can choose any order we want. As long as we do the same 4 things, it will still be okay. No, it is not okay. we have to do it in this specific order. And that's why it's called a sequence. Are there any questions about everything that we have talked about so far? If you have a question to ask, this would be a good time, before we move on to more complex type of constructs. If this is all that you can do in a program, what do you think?
Lots of fun.
How do we write Microsoft Word using only assignment statements? Probably not going to happen. Okay? Because what we are lacking is the concept of making a decision. Sometimes I want to do this, other times I want to do something else. All right, so let's go ahead. Let me save it first, just so that I can remember to upload it later. And we'll create a new folder. This is what I usually do, is I create a folder for today. So later on, if someone reminds me to upload all the documents, I only have to zip up the folder and then upload the zip file. So I'm going to save this one as simple sequence. Go. So now it is all saved. I'll close this. And then I'll go back to, not this one. I was teaching base conversion in cisp300. We'll go back to this one. Okay. How would you specify the logic to find the maximum of two variables, of two values, basically? Well, let's look at a few scenarios. Okay, so I'm gonna put a little divider here. Okay, and I'll say I want to find the maximum of x and y, and store that maximum in W. This is what I want to do. Can I do this using just assignment statements and sequences? Why not? What about this? If I just say W gets the value of x, would that solve the problem? No. Sometimes maybe it's the right answer, but other times it's the wrong answer, right? Because it depends on whether x is greater than y or not. So that means, this is not the right answer sometimes. What about this one? It's the same, right? What if x is greater than y? Then if you update W to become y, that will be the wrong answer. What is that telling you? Why can't either one of these answers solve the problem?
Because it's not finding for both x and y, only
Because
one or the other.
It can only do one or the other all the time. Okay, if I pick the first one, then W will always be updated to the value of x. If I pick the second one, it's always going to be updated to the value of y. So it's lacking something. What is it lacking? It's lacking the ability to choose, right? It's lacking a conditional statement. Okay, very good. So the solution to this is what we call a conditional statement. Now, to understand what a conditional statement is, okay, let me just go back to Moodle, because we are done with this part. Let me show you where we are at this point in terms of the notes. We are now moving on to conditional statements. Now, this is a good way to show you too, because I just read my own notes in this sequence. In other words, when you have time, you can read way ahead of me. Okay, you can just keep on reading, because I just present the material in this particular order. This is basically your quote-unquote textbook. Any questions about how I teach this class and where you can get the reading material for this class? Questions? You don't have to pay anything for this. It's all free. Internet and free. I try to read this stuff on my cell phone. It's actually very readable on a cell phone. Can anyone guess why?
Mobile site.
No, it has to do with how I format the web pages. It's very simple. There's nothing fancy on these web pages. So when you use your cell phone to read this material, it shows up just fine. There's no, it doesn't need a widescreen. It doesn't need anything special on the browser side. All right. So we are moving on to conditional statements, and I want to use it, open it in a tab. The why part, we just talked about it, okay? But since this is called a conditional statement, we first have to understand what a condition is. A condition is basically a question. In other words, every time I present a condition, you can look at it as a question. Except it is a very specific kind of question because it can only have one of two possible answers. The answer can either be true or false. Those are the only two answers an answer can provide. The rest of this really is just talking about why we do not use yes, no, because that has to do with a language and cultural thing. In some culture, I think they will answer yes, and in another culture, the answer will be no, depending on the context. So that's why we don't use yes or no. We just say it is true that x is greater than y, or it is false that x is greater than y. And then we move on to really complex stuff, like comparisons. If you just kind of ignore the stuff on the right hand side, do these symbols look familiar to you?
Yes.
Okay. I was worrying a little bit there, because if someone said, no, all of these symbols are pretty new to me, I don't really know what they mean, then I'm in big trouble because then I have to explain all this stuff. Okay, so you're already familiar with all these relational operators. They're also called relational operators because they relate the left-hand side, the value of the left-hand side to the value of the right-hand side. We have greater than, less than. Now this one, we know what it means, but it is really hard to type it on the keyboard, okay? With HTML, there is a key, there's a ampersand, to do it. There's a, how do you call those things? An element? Sorry. But there's a way to input this symbol. If you use a word processing software, you can probably input that as well by insert symbol and then pick it out of the math symbols. So, but in programming, we just use a greater than followed by an equal symbol to represent greater than or equal to. It's just a quick and easy way instead of trying to do something that makes it look right. And also less than or equal to, same thing. We use less than followed by a equal to symbol. Not equal to. Now not equal to is a little bit different because in C and C++, it is represented by an exclamation point followed by an equal symbol. But in most other languages, it is represented by less than greater than. Does it make sense that less than greater than means not equal to? Well, because it's less than or greater than. If x is less than or greater than y, that really means x and y are different. So less than greater than makes sense because it is exactly what not equal to means. And we also have equal to, and this is why I don't use the equal symbol to represent assignment, because they mean two different things. When we use the equal symbol, we are asking the question, is it true or is it false that the left-hand side have the same value as the right-hand side? That's the question. It can either be true or false. When we use the assignment operator, which is a left arrow in this class, we are saying evaluate the right-hand side and then update the value of the left-hand side. And that's why they're completely different things. I do not want to use the same symbol in this class for that. What about in C? Well, you already know what in C how we represent equal to. In C, equal to is two equal symbols. In C, C++, Java, and most other C-derived languages. So that would include PHP, Perl. I don't know Python well enough to know. Does anyone know?
Python is 2.
Yeah.
2 equals to? Okay, 2 equal to. In some other languages, like Visual Basic, SQL, and Pascal, it is just a single equal symbol. Here comes the next question. In C and C++ and Java and PHP and Perl and Python, what if you accidentally use one equal symbol instead of double equal? It depends. It depends on what is on the left-hand side. If you only have a single variable on the left-hand side, it is not a syntax error, but it is definitely a semantic error. So your program will not do what you think it is going to do, because instead of comparing the two sides and give you true, false as an answer, it's going to change the left-hand side. But you would say, but that's not possible because the context of compare, or using the equal to, should not allow anything to be updated, right? Well, in a normal and sane programming language, yes. But C is not one of those. So you can have an assignment operation going where you're expecting a compare operation. So you have to be extra careful in C programming, because somebody in this class, I would say a few people in this class, let me say 10% at least, will make this mistake. The intention is to compare, but the result is a single equal, which is an update operation. It will update the left-hand side. Is there a way to stop this insanity? Yes. Quick and easy way to fix this insanity is to respect the compiler. The compiler is what is translating your code written in this form into a form where the processor can execute. It's a translation, but it also does all sorts of changing, like sanity check. Okay, when you use the equal symbol, when you use the assignment operation, where it makes more sense to use the comparison operation, most compilers will nag you and say, hey, this is really suspicious. Is that really what you want to do? Do you know what most programmers will do? Okay. Ignore that, right? Just like, Mom, I know. Okay, and then the program doesn't work,
And then says, I told you so.
Well, the compiler doesn't quite get that line yet. Yeah, I have to change the compiler so that it can remember what error messages it had given you before and track how you change the program. So when you make changes to the program, but only after a long time, after it complains about the same thing, it will just on top of the error message, and it will just in parentheses say, told you so. So remember this, okay? You may not understand this completely in this class, but just remember in 360, double equal and single equal operators are completely different things, and a lot of times you can confuse one with the other. It does not generate any error messages, it only gives you a warning. So pay attention to the warning messages. Okay, comparison stuff is easy. What about logical operators? We'll talk about logical operators later, because right now we want to kind of just move on and talk about what a conditional statement looks like. A conditional statement looks like this. Okay, in this case, in this particular example, I kind of switched the variables a little bit. I want to find the maximum of x and y. I want z to store the maximum, in this case, not w. Well, minor changes, but basically the same thing. The pseudocode to represent it is like this. Okay, this is what we call pseudocode. I never really talked about pseudocode earlier because I skipped that whole chapter. Pseudocode means, pseudo means vague, not real. Okay, code in this case means program. So this is not real program. In other words, no compiler can translate this into a form where a processor can execute. What's the point? Aren't we wasting our time?
It's for us to understand.
It's for us to understand, exactly. It's for programmers or people who write algorithms to communicate to other people who write algorithms. Well, but I have a problem here. We can just use a particular programming language, can't we? We can just pick C or Java or Pascal or PHP. So why do we want to use some form of code that is not real, and yet it is used to represent algorithms that are intended for computers to execute?
Would this be multilingual, basically, so that way people using different languages can type it into their program?
Exactly. It's a universal language. In other words, and also the syntax is not really important. Okay? If the intention is just to represent the logic, what if someone types the same logic but somehow, just did not use the word then. Just say, if x is greater than y, z gets x, else z gets y, and if. It's just as clear to me, okay? It's not a problem. What if someone doesn't like and if being two words and decide to kind of merge these two words into and if as one word? Do you think I can still understand it? It's fine. What if someone likes uppercase and lowercase, uppercase if, uppercase else, uppercase and? It's fine. What if you miss a semicolon in a C program? What do you think the C compiler would do? It gives you like this much error messages, right? For one missing semicolon. Well, not exactly, but depending on where the semicolon is, it can give you a lot of error messages. The compiler has no tolerance whatsoever to any type of grammatical mistake. But people do. I mean, as long as I understand the logic, it's good to go. And that's why we use pseudocode in classes like this, where the focus is not the syntax of the language. The focus is the logic of what we are doing, with the program. Are there any questions about the role, why we use pseudocode in a class like this? Ideally speaking, after this class, when you take the C class, your only burden will be getting used to the syntax of C, but not the concept of the statements. Because C has conditional statements, just like we talk about conditional statements in this class. C has loops, just like we will talk about loops in this class. C has subroutines, just like we talk about subroutines in this class. The syntax is different, but the concepts are exactly the same. So when you take the C class, ideally speaking, the syntax or the grammar of the language should be the only thing that is on top of what you already know. But the content or the meaning of the statements should still be the same as what we talk about in this class, and it should not be an extra burden when you take cisp300. When you look at this code here, it may not be very clear what it does. But what if I give you a picture to represent what it does? This is the picture. So let me see if I can display it side by side. Size one of them. So I can show both the. All right, that's good. So now we have a pictorial representation on the right-hand side and a pseudocode representation on the left-hand side, meaning they represent the same logic. Let's look at the pictorial representation. This is kind of like a trail map. Now, when you are on a trail and you encounter a fork, a branch, okay, can you be on both paths at the same time?
No.
Well, a quantum physics teacher may say that yes, but this is not a quantum physics class, and therefore the answer is no. You can only take one branch at a time. So that means you have to pick which branch you want to, you want to walk on, and that's why we have a little post here asking a question. X is greater than y. It is not a statement. It doesn't say that x has to be greater than y. It's a question asking, is it true or is it false that x is greater than y? That's what that little rectangle is representing. It's a question. The answer of that question can only be true or false. If the answer of this question is true, we follow this path. If the answer of this question is false, then you follow the other path. In other words, there's one single question, and your answer to that question will determine which way you go in the case of a branch. Are we doing okay so far with the concept of a branch? Two ways to proceed, you have to pick one. And the way to pick one is your answer to a particular question. The then branch is specifying this statement here, which means z is updated to the value of x. The else branch, which is the branch that you take when the condition is false, is to update the value of z so it has the value of y. Yep.
What would this little pseudocode thing do if x equals y?
If x does equal to y, well, let me finish this and then I'll address that. That's a very good question. Now, regardless of which branch you take, they will both merge to the same branch when you exit this path, which is a very important characteristic of a conditional statement. It only matters when you come in, which one should I take? But after each branch, they both merge to the same point of exit. Because the exit goes to the next statement. You don't want the exit to go to different statements because this is a single statement. To answer your question, which is a very good question, is what happens when x and y have exactly the same value? Well, we'll go ahead and do it the same way as a computer do it, which is asking the question. Let's just give us a more concrete example. X and y are both 3. 3 is greater than 3. Is it true or is it false that 3 is greater than 3?
False.
False. Well, that gives you the answer. We'll take the false branch, which means we'll go to the else, and then y will be used to update z. But in that case, it doesn't matter which way you go, right? Because x and y are the same, so which way you go, you will still end up with the same value in z. But it will go for the else branch because 3 is not greater than 3. Does that make sense? Okay. We still have about 3 more minutes, so we'll keep on going until we run out of time. All right. In many classes, at this point, we'll talk about like flowcharts and stuff like that. I don't use flowcharts. I don't want you to use flowcharts. I want you to forget the use of flowcharts. Okay? Why do you think I do not like to use flowcharts? I mean, flowcharts are nice. I mean, if I just write it on the whiteboard, the flowchart would look like this. A diamond represents a decision-making process. X is greater than y. You come in, true, you go this way. False, you go this way. You do something here, you do something here, and then these will merge over here, and then you exit. It's the same as the little trail diagram. Well, unfortunately, flowcharts also encourage what we call spaghetti code. Can anyone guess what spaghetti code means? Let me be more specific. Cooked spaghetti code. Because before you cook spaghetti, they're pretty easy and uniform. But after you cook spaghetti, what do they look like in a pot? Right? What if your program, or logic of the program is also like this?
It's gonna be a mess.
It's a mess to track down, right? Flowcharts can easily allow spaghetti code to happen. Okay? Now the trail diagrams, you might think that, but it's the same thing. It's representing the same thing. Why? How come that will not have a problem? Later on, you will see why it's not going to lead to the same problem. It has to do with one simple fact. The trail diagram has a containment. You only have one way to come in. You only have one way to go out. One block represents what you do when the expression is true. One block represents what happens when the expression is false. When you look at the construct of a flowchart, it allows you to specify something way different from what we are trying to represent here. Okay? You can always add another diamond, right? Every time you add a diamond, you can now have another branch. You can add another one here that goes straight here and emerges over here. Do you see what I'm doing here? This is the beginning of spaghetti code. Because this code becomes unrepresentable using pseudocode. Why do you think it's a problem when this is no longer representable using pseudocode? Remember, pseudocode is quote unquote the common language of all programming languages, right? So if this is no longer representable using pseudocode, how do you specify this in C?
You can't.
Not easily, not without having your grade affected, because you will need to use gotos, which is a 4-letter word that is considered taboo in programming. We call it the G word. You do not use the G word when you're programming. Okay? And to represent something like this, you will have to use the G word. Okay? We are running out of time. Well, I guess we have 20 seconds. I'll let you guys get out early by 20 seconds. When we come back on Thursday, we'll continue the discussion of conditional statements, but we will also move on to loops. So you want to read ahead of me and read the loops part as well before next class. Who has the row sheet?
It's right here.
Oh, okay, thanks.
I was wondering if you're still not giving out the numbers?
Here.
Condition numbers?